this session is Chung Chen. He's currently a research staff at the Distributed Lab, Central Software Institute of Huawei. Chung received his Bachelor of Engineering degree and Master of Engineering degree in the School of Computer Science and Technology, Huazhong University of Science and Technology, Wuhan, China. His research interests lie in serverless computing. All right.
Okay, thanks for the introduction. Good afternoon, everyone. My name is Chung Chen. Today, I will present our work, YuanRong, directed by Quentin. YuanRong is a general-purpose serverless platform designed to scale any distributed workloads at Huawei. Before diving into the details, let me first introduce the meaning of YuanRong. As shown in the figure, YuanRong means giant chariot in ancient China. Here, Yuan means the bigger, and the Rong means the chariot. In recent years, serverless computing emerges as the next cloud computing, offering three key benefits, such as providing a high-level abstraction and auto-scaling and pay-as-you-go model. Due to these key benefits, major cloud providers have rolled out their own service offerings, such as function as a service, AWS Lambda, and the serverless backend service, such as S3, and quickly adopted by simple request handler applications. However, application developers are still facing many challenges when they are building complex applications purely with these serverless offerings. Many complex applications usually require coordination among various components, and some of which typically stateful. Let's take a microservice-based social network application as an example. As we can see in this picture, a single request upload to a social media post may trigger 15 stateless RPC calls, and most of them are internal calls in the microservice architecture. When implementing these use files, these functions are not addressable, so the calls between functions must go through the front end, resulting in non-latency. Second, some components are made stateful, such as it needs to maintain the follower counts. So in the current fast design, functions are stateless. The state management relies the remote storage to realize the remote storage. And this not only leads to non-access latency, but also may faces vary and low bandwidth. Specifically, we identify 5 challenges of the existing serverless platforms. The first 2 challenges, such as state management and fine-grained coordination, have been introduced. The third challenge is the non-cold start problem, which is a major performance hurdle for serverless applications to achieve extreme elasticity. The fourth challenge is the complex interactions. Developers need to integrate the backend SDKs into their functions. And when cloud providers update their backend SDKs, the developers also need to update their functions, which is cumbersome. Moreover, the backend service interfaces offered by different cloud providers may vary greatly. So it's difficult to deploy their applications across multiple clouds, raising the concern about vendor lock-in. To address these challenges, we propose YuanRong, a general-purpose service platform that scales any distributed workloads at any scale with both functions and containers. This means we allow developers to provide their customer container images, which are then managed and scheduled by our platform. This figure shows the architecture of YuanRong. YuanRong exposes an open serverless interfaces, which for interacting with the function instance and the distributed shared memory and also the backend services. Given many applications may develop using popular languages, so we also provide a multi-language runtime, which enable developers to build their applications using their family languages. The core of YuanRong is the underlying distributed caller, which holistically solves the 5 challenges and ensures high performance. To solve the state management challenges, we develop a multi-semantic and built-in data system, which provides a low latency, high throughput data cache through a distributed shared memory pool. To solve the fine-grained coordination and cold start problem challenging, we design a faster function system, which supports function-to-function invocation and heuristical distributed scheduling and quick function start. To solve the bus interactions and multi-cloud deployment challenges, we also develop a portable bridge system, which provides a unified backend abstraction and enables collection reuse and distributed transactions. Next, we will show the technical designs of YuanRong. This figure shows a breakdown of Java applications called start-time, where we find that the application initialization latency is more time-consuming and is harder to reduce since it is application-specific and also varies greatly. To address this, we propose a process-level snapshot-based approach named Quick Start, as shown in the figure. First, we checkpoint a snapshot of the function imaging and after the initialization in the pre-running stage. Then during the production stage, when subsequent invocations to the same functions, we directly restore the snapshot and skip the time-consuming application initialization process. Our experience shows that it could reduce 10 to 16 in times reduce for our business Mac service. Also, next, we also provide to support the efficient data management and the data exchange among function instances. We also provide a distributed shared object memory pool. As shown in the figure, on each node, we employ a data worker that is responsible for the transferring and catching the object copies. Functions only interact with this data with the local data worker via shared memory to achieve low latency. We also provide the pass-by-reference semantics to allow functions synchronous execution and support the on-demand resolving to avoid unnecessary data movements. Our experience shows that the data access performance also is significantly better than Redis due to the local cache read-write and the zero-copy-based shared memory. For more details, can be referred to our paper. Next, we will show the adoption of YuanRong. We started the project in 2019 and launched the first fast service in 2020. Since 2021, we began to expand expand YuanRong to support general-purpose workloads such as the stateful web services. Currently, YuanRong has been deployed in nearly 20 regions across Huawei and achieving the daily usage over 15%. Now, YuanRong serves general workloads across web service, big data, HPC, and AI workloads. First, let me show YuanRong that also supports the short-lived fast service. As shown in the figure, nearly 50% functions that run short than 240 milliseconds, and almost all functions are run complete within 2 seconds. In these scenarios, the platform overhead of YuanRong, about the P90 latency remains below the 35 milliseconds, which thanks to our distributed scheduling design. Okay, next, in the summer of 2022, we began to help our customers to port their Mac service to YuanRong. The motivation behind this migration is to increase resource utilization and save cost. However, achieve this is not easy. The first challenge is our customers do not want to make significant changes to their code. So to address this, we first allow our customers to complete the migration as a whole container image with 0 modifications. This is achieved by supporting the management and the scheduling of Mac service in the form of container images, while ensuring performance not degraded. Since we allow direct calls between the container-based and function-based Mac service in YuanRong, as shown in the right figure. Further, we'll also provide another way for our customers to achieve the incremental migration with minimal modifications. Considering that most of our customers are using Spring Framework to build their Mac services, so we also build a custom Spring Framework that by replacing the components responsible for the request handling and the transmission, allowing it to run as a whole function in YuanRong. We further suggest our customers to split their Mac service-based applications into fine-grained functions based on the core frequency of each interfaces to further improve the resource usage by reducing the reserved resources during the no-demand periods. Finally, the resource cost reduced up to 19% compared to the over-provisioning methods. However, as seen in the left figure, when the function-based Mac service need to perform the transaction operations on the same databases through multiple user functions, which may introduce the transaction consistency problems. To address this, we propose the service bridge. As shown in the right figure, we first offer a collection of pre-built bridge function instances that intercept the request from the user functions and translate them into the specific request to the backend. By controlling the request routing, we can convert the distributed transactions across multiple user functions through the local transactions and ensure the transaction consistency. Till now, thousands of Mac servers have migrated to YuanRong, most of which can be easily done within one day. Last, we also helped our customers to parallelize their graph-based HPC applications using YuanRong. The biggest challenge is the computation process constitutes a complex and dynamic DAG. The message passing in programming requires developers to clarify the dependency and set synchronization points, make development difficult. So to address this, we propose a unified programming API, and also uses the pass-by-reference semantics to construct the dynamic graph. This means developers do not need to consider the synchronizations and can use the features to pass the data to the next functions. The figure shows the result. We can see YuanRong can scale to 10,000 scores while achieve the 8 speed up compared to 1,000 cores. For more experimental details, please refer to our paper. In summary, serverless computing represents the next cloud computing paradigm. But the current design exists many limitations to support general purpose workloads. To address this, we propose YuanRong, a general purpose serverless platform in production by resolving all issues of the state-of-the-art serverless techniques. YuanRong is still evolving to support the emerging in serverless LLM workloads in the future. Thank you.
So you say your users have migrated to this platform.
Yeah.
How much reduction in price have they seen by migrating to this platform for their existing applications? How much money did a user save?
We only helped our internal customers to migrate to our platform. So it about hundreds of millions maybe.
I also have a question. Like you mentioned, there's like 90% cost savings after the internal migration to serverless functions.
Yeah.
Where are those like savings from primarily?
The reason is the traditional microservice-based methods. It need to reserve many resources according to the peak demand. So after migrating to YuanRong, we can auto-scaling the workloads and free the resources when there is no demand.
Could I ask one more?
Sure, one last.
Yeah. Did you get any statistics on the reduction in cold start latency when you had your users migrate to this platform?
The latency when translate the microservice to our platform, maybe it may increase one millisecond.